Hey folks, before we get into today's podcast, I wanted to let you know about our upcoming QCon software development conferences. We will be back in person with QCon London this April 4th through 6th and online with QCon Plus conference May 10th through 20th. Join the world's most innovative senior software engineers across multiple domains, in person and online, as they share their real world implementation of emerging trends and practices. You can learn more about the events at qconferences.com. We hope to see you there. Hi everyone, my name is Srini Penchikala. I am the lead editor for the AI ML and the data engineering community at the InfoQ website. Thank you for tuning into this webcast. In today's podcast, I will be speaking with Jaxon Repp, head of product for HarperDB database. We will discuss the HarperDB database from technical architecture and the data management capabilities, and also how it supports cloud-based data management use cases. Let me introduce our guest first. Jackson has 25 years of experience architecting, designing, and developing enterprise software. He is the founder of three technology startups and has consulted on multiple IoT and digital transformation initiatives. Jackson, thank you for joining me today in this podcast. Before we get started, do you have any additional comments about your work at HarperDB that you would like to share with our audience?
No, just I'm honored to be here and thank you very much for having me. I'm excited to tell you a little bit more about what we're doing.
Sounds good. Yeah, thank you for your time. For our listeners who are new to HarperDB, can you give us a brief description of the database and what type of data management use cases it's a good solution to consider?
HarperDB is a distributed database. At its core storage, we are SQL and NoSQL. So we can store traditional rows and columns. We can also store a document format. But we combine that with the power of ANSI compliant SQL. So you can join tables and even join on nested values within JSON between multiple tables, or a MongoDB corollary would be collections, which is something that most document stores have trouble with. So we give you the power of the SQL you already know with the flexibility and the speed of a document store like a MongoDB. In addition, we have a unique algorithm for replicating data between nodes of HarperDB that we call clustering, but it is a table level bidirectional configuration. So you don't need to move all of the data to all of the nodes. You can have certain pieces of data, subsets or tables, residing on, say, an edge server where the cloud might have everything, and another edge server might have a different subset of data. So it's extremely efficient and works with just about any data topology you can imagine.
Excellent. Regarding the clustering and also how the data is managed, can you discuss the data storage and the architecture of HarperDB? How your team was able to build the product from the ground up, and any interesting architectural innovations used in developing the database product?
One of the things we as developers were running into constantly was issues with performance over time. When you're in a greenfield development, you build the best data structure you can, and then inevitably something arises that throws all of your logic and all of your best laid plans to waste. And now you've got a billion rows in a database and you want to add a new index, and you kind of have to shut down for the weekend and hope that that thing builds in time for the Monday crush. We wanted to build a system that didn't duplicate data, would be smaller on disk, still highly efficient and performant, but ultimately lower maintenance as well. So by default, we index all top level attributes in a table. So you don't have to worry about managing your indexes because everything's indexed by default. Obviously, that contributes to slightly more storage on disk, but we don't actually replicate the entire data set in an index, only the hash attributes or the attributes that we're tracking. Initially, we did this using symlinks on the Linux file system. Ultimately, we ran into an inode issue and we rebuilt the entire product a few years ago on top of LMDB, which is a memory mapped key value store. Extremely performant and has the additional benefit of allowing for non-blocking writes, which allows us to be performant for reads, i.e. analytics or other workloads where you're doing lots of queries, while at the same time pushing data into the database and not suffering from a performance hit for that.
Okay, yeah, you mentioned about LMDB being the key value database. That's the foundation for HarperDB. But from a developer standpoint, the database can be used for different types of data structures like a document type or key value, or like Cassandra supports the other data type and also graph data type, right? So can you talk a little bit about that? What type of data is best, for HarperDB usage? And if there are any particular data structures or use cases that are not good to use HarperDB.
No, I would say we are highly performant on top of for every sort of data structure. That was the flexibility ultimately that we wanted to achieve with this product, because it was one of those things where all of a sudden you have a new value that's going to go into the database. So you need to change the size of that field. And that's a massive pain. We didn't want to have to deal with that. So we love the flexibility of document stores like a MongoDB. But ultimately, we wanted something that was more performant and allowed us to integrate traditional SQL as well. So when I mentioned LMDB is our underpinning key value store, that allowed us to have extremely fast and non-blocking ability to persist the data. And then our data model, which lies on top of that, is what allows you all of the flexibility to then break those things down into ultimately what LMDB stores as a key value, a set of keys and values.
Right. I know you mentioned about the performance as well as the SQL, relational database kind of support. So usually that is the kind of the dynamics between these different options, like a SQL versus NoSQL, where SQL supports the transactionality and immediate consistency, right? And with some performance hit. Whereas the NoSQL databases, they are meant for performance, but they do come at a cost in terms of the consistency and the transaction management. So how did you guys balance these two somewhat, perceivingly conflicting challenges, and how are you able to achieve both?
We are ACID compliant at the node level. So we adhere to consistency on disk, similar to more established SQL databases. And we are eventually consistent across the cluster. So we accept that two people might try to write something on opposite sides of the globe, and then it's our job to reconcile that. We use that with using a universal clock. We're investigating CRDTs. We have lots of algorithms to prevent duplication of data. And to be honest, right now, the last writer wins based on a timestamp. But as we replicate data around the system, we have lots of compares to make sure that the right data ends up at the right place around that cluster. There are competitive products that sacrifice speed, even in the distributed computing world, where you basically do a global row lock. CockroachDB is a great example, extremely performant on a global level and ACID compliant. And they do that by basically locking a row before they write it anywhere. It's great for financial services, so nobody can ever take the same dollar out of the account at the same time from opposite sides of the globe. But for the other 99% of transactions, customers, and applications, eventual consistency is sufficient. And that's the portion of the market that we decided to go after. That's not to say we won't add a toggle somewhere down the line that does global row locking. But right now, we have plenty on our plate just selling distributed computing and the advantages that come with that.
Right. Yeah. Most of the use cases are typically kind of needing the performance more than the consistency, right? And there are a few use cases, like you said, financial institutions, transaction is more important, right? So
exactly. Our biggest success in proofs of concept have been things like AI, ML, like classifications at the edge where anomalies might be replicated up the chain, rolled into a new model, the new model then distributed back down to the edge, or social media / gaming or entertainment where you might want a friends list. There's no penalty for adding a friend and getting it like a half second later, or dropping a friend and having them hang out there for a half second on the other side of the planet, or 110 milliseconds is usually what our global data replication takes. So, when it's not mission critical that we lock everything out, the speed that is delivered by having the data close to the edge far outstrips every other architecture when you're looking at a single monolithic data store in a single region and the massive round trips from your distributed API endpoints back to that data source.
right. Also, you mentioned earlier, how HarperDB manages the data consistency at the node level and the cluster level. Can you discuss a little bit more about how the distributed, peer-to-peer read and write consistency works, and how does the API distribution is designed in HarperDB?
Our clustering is peer-to-peer. It's pub-sub. So one node can initiate a connection to another node, say an edge node that has access up to the cloud, where the cloud might not have access down through a firewall to an edge node. And that edge node can subscribe to tables where it's managed perhaps in the cloud, and it could say thresholds. It's doing analysis of sensor data. It is recording those values on a first in, first out, maybe 30 minutes worth of sensor data. It subscribes to thresholds from the cloud. It's recording the data locally, but not sending that anywhere until a threshold is violated, at which point it creates an event using perhaps the 30 minutes of leading data. The event data itself wraps that up in a package and inserts that package into the events table, which would then be replicated back up to the cloud. So you don't move all of the data. You only move the parts that are necessary. Now, when you've got 1,000 edge nodes and they are writing events to the events table, obviously we would have a key in those attributes that say, I came from machine 1 or machine 2 or machine 3. A lot of times, if you have multiple applications writing to the same instance of HarperDB and then distributing those out, or the same table in HarperDB, we effectively take the transaction, which is just the change set to that data, and we replicate that around the network to all the nodes that are supposed to possess that data. So the result is that the transaction itself doesn't go to every node, only the change in data, which is a lot less. So we like to lower network traffic and ultimately lower the load on everybody but ourselves from that algorithm that says this is supposed to be written before this overwrites that one comes before, but here's how that would reconcile. And we do all of that without anybody having to worry about it.
Right. Also, you mentioned about edge computing a little bit, right? So most of the modern data use cases include some kind of edge device, right? Whether it's a smartphone or some kind of a device in a factory or even the vehicles, cars in terms of autonomous vehicle technologies. Can you talk more about that? Can HarperDB be installed at all these different nodes or devices? I know HarperDB can be used for smaller as well as larger applications. Can you talk more from the edge persistence standpoint, how it works?
We've run on machines as small as little Jetson boards or Raspberry Pis. We have a 100 meg footprint, and we use, as I mentioned, LMDB as an embedded database. So there's no ongoing process sucking up CPU until such time as you hit the operations API and begin executing a workload. So we're not resource intensive, and we don't have a large footprint. Obviously, your data may have a large footprint, so you're going to be constrained by the size of what you choose to put on disk. But ultimately, we found that as much as we would refine our query engine or the speed of our API, we had Express when we started, and now we use Fastify, for example. And Fastify turns out to be twice as fast. There was no substitute for moving the transaction closer to the user. We can save, from 5-second total query time to 10 millisecond total query time when we move the application layer, i.e. our custom functions, and the data out to, say, a Verizon wavelength server, and you're on the Verizon network over 5G, and you connect to that application and you see data in the single digit millisecond response times. There's almost no optimization I can do to our internal product that will ever save that much time. So the edge is a huge play for databases because we just look faster because of where we are. It's a very, very easy decision to make as long as your data retention policies and your comfort with eventual consistency meets your application's needs.
Right. Along with cloud computing and edge computing, another area that's been getting a lot of attention in terms of the databases is the serverless architecture. HarperDB supports custom functions. So can you talk about how these custom functions work and what does this mean to database developers as well as application or API developers? How can they leverage this interface to work with the database?
HarperDB comes with what we call our operations API. It's an HTTP API where you can execute all of your queries, operations, inserts, start jobs, exports, stuff like that. And that is, as I mentioned, run on a Fastify server that then has access to core HTTP methods and executes whatever operation you send in. We love that format because almost every application is already making HTTP calls, and figuring out your connectors or your drivers is always such a pain. And HTTP is super easy, so it's also very atomic and it's very fast. There's not a lot of overhead attached to it. We thought it would be great if you could define your own operations, so we added to HarperDB a standalone Fastify server that you can restart without affecting the core HarperDB ingestion and operations. And then you can use traditional Fastify routes and all of their hooks and all of their handlers to effectively set up your own API endpoints. And within those routes and those handlers, you have access to core HTTP methods. So where you might normally, with an application, set up a serverless, a Lambda function on AWS, you would reach through, say, API gateway, you would hit the Lambda would then make another HTTP call to HarperDB and make that hop. Whereas in this architecture, you hit the Lambda basically sitting in a Fastify handler directly on the machine next to the data. And then instead of making that second hop, it just directly queries the embedded LMDB key store through our data model. And that's how you end up with 2 to 4 millisecond response times when you're on the edge querying massive data sets. And in the social media and gaming space, that's why we're having success, is that things that used to take maybe 11 seconds if you were in South America. That round trip to US West 1 takes a long time, up to 11 seconds to get your friends list back. And we were able to move a HarperDB server with custom functions to a data center in Buenos Aires. And boom, you were seeing 20 millisecond response times at peak.
Speaking of the API, to access database, can you talk about does HarperDB support GraphQL or any other type of application API interfaces?
It's interesting that that's our number one requested feature is a GraphQL interface. And when we launch custom functions, they are project based. So you create a folder, there's routes in there, there's helpers, you can include any NPM package you'd like and build that thing as a project and then distribute that project to all of your nodes. The first project we actually deployed, and it's available on our Git repository, is a RESTful interface. So truly RESTful compliant. I'm going to go to this schema, this table, this ID, and it's going to return me that result. I can post to it and update it. I can patch. It follows the spec perfectly. And then we thought this is a much better solution. Rather than building in the functionality for GraphQL, we will work on a custom functions project that is a GraphQL basically interface. And so we're working on that now. We're planning it. But what we're really excited about is the fact that since it's the number one requested feature, we hope that as soon as we release version 1, the community is going to lovingly adopt it and make it even better. So we have a very passionate developer community and a developer Slack where we are constantly getting questions about, this is how I used to architect solutions. This is kind of the table structure. Is this right? And it's refreshing and rewarding to be able to say, it doesn't have to be that hard anymore. It can be a lot easier than that. Just do it this way and it'll solve all your problems. And to watch people who maybe are familiar with, say, a MongoDB and that flexibility, learn how simple it is to join things or to insert data or what the performance levels are. I think almost everybody's probably started an application using MongoDB and eventually run into the bottlenecks that you'll eventually run into. But likewise, people who are traditionally using RDBMS are still able to use their SQL queries. They can move them right over. They can transfer data directly out of Postgres, and they can effectively just move the queries in their app into custom functions, and it still just works. So it's a very flexible platform, and all of the additional interfaces, including a WebSocket subscription where you could simply subscribe to changes in a table. All of those will be built as example custom function projects that then people can just get cloned directly into their custom functions folder, fire it up, and it should just work.
Yeah, that's a good point. You mentioned that the reactive architectures are getting a lot of attention. So by leveraging WebSockets, the developers can get that side of the development as well. And so you mentioned about performance and scalability a couple of times, the metrics. So do you have resources or benchmark studies the InfoQ listeners can check out, especially to kind of see how it compares with other databases in the SQL and the NoSQL spaces?
Absolutely. If you go to our website at harperdb.io, go to product, and then under that, there are benchmarks. And we have them for most major platforms.
And another important aspect, of any database or any application in general is security. So can you briefly talk about what kind of security features HarperDB supports out of the box in terms of authentication, authorization, and data encryption, and so on?
We support basic auth through our operations API, as well as JWT auth. So you can generate a token and then use that for future transactions. Within custom functions, you can leverage the same basic auth or token auth, but you could also write your own auth handler. I wrote one for Azure AD for a customer. So you can implement effectively anything you want on those custom functions. From a security perspective, if you'd prefer to completely control the experience, you can actually shut off the operations API and only use custom functions. So you can close down access points to HarperDB and restrict them to only the ones that you want to have. Once you're in and authenticated, we have a role-based security where users can be assigned to roles. Within roles, we allow for basically attribute/operation level security. So I can grant one role read access to a table where they return all of the columns except the ones with personally identifiable information. So when they do select star, they'll get back some account details and technical details, but they won't get a name or address or phone number. Meanwhile, the account team, they won't get any of the technical details if they don't need them, and they'll get back the name and the address and the phone number. So you can control data incredibly granularly, including not just reads, but writes, updates, and deletes. So an edge node may only have permission to write 3 attributes into a table, whereas another application that is following up on an alert might have the ability to write, say, 3 more columns because now there's more data further down the line. That's incredibly powerful. We don't currently encrypt data at rest. We have customers who encrypt full disk, and there's a small performance penalty for that, obviously. But we thought there's lots of people going after that. We are looking at encryption strategies like homomorphic encryption, where it is not only encrypted at rest, but it is encrypted while you query it. So it will be fully encrypted end to end, including when you send it in over SSL, and then immediately wrapped up and pushed into persistence. And it is never not encrypted until you get the result set back. And then that endpoint will simply decrypt it on the way out, transmit it over SSL. That is a forward-looking project. As we push further into the cloud and further into simplifying deployment of a data fabric, a global data fabric, in future iterations of our HarperDB cloud offering, I think that abstracting away all of the complexity and the worries of security and speed and networking and clustering logic, the simpler we can make it, the more our customers seem to like it. I think the old paradigm of, I want to install this on bare metal and I've got a DBA and he's the only person with the keys and God forbid he gets hit by a bus, but man, he's really in charge of our indexes. I think we like to turn a lot of those assumptions and traditions on their head, and our customers seem to be nothing but grateful for our efforts.
And also it helps with the faster time to market.
It does. The sales cycle shortens considerably when you can answer, we already do that, to every single question they ask.
That's how we bring the database tier into the agile development spectrum, right? So since HarperDB is a kind of a relatively new database in the industry, like where can our listeners find more about it? Obviously, our website. Are there any other resources you can share, that they can learn more about it?
To start, HarperDB is an NPM package. So we are built in Node.js, but we are ultimately a Node.js, an NPM package that you can install just by typing npm I HarperDB. Super easy, assuming you have Node.js and NPM installed, obviously. More details can be found in our docs at docs.harperdb.io. And we have, as I mentioned, a HarperDB Cloud database as a service offering with a free tier where you can log online to our studio, our management studio at studio.harperdb.io, spin up a free instance, and get started right away. There are code samples that you can drop in just about every language into your application to demonstrate how to set up a schema, how to set up a table, how to push data in, how to import a CSV, all of which you can manage through the studio. And then you can always install instances locally on your own machine. And we also have a Docker container. All of those install instructions are, again, at docs.harperdb.io.
Also, in terms of open source and community participation, the HarperDB is not fully open sourced yet. Can you talk about, what are the plans? Will it be open source solution in the future? What is the roadmap?
We considered open sourcing this product a great deal, but at the end of the day, we've seen a lot of really great databases with incredible features. Some of the names fail me, but they fail me because they are now no longer a thing, because it's hard to get people to work on something for free. Even MySQL is fostered somewhat by a multi-billion-dollar corporation. We don't have billions of dollars at HarperDB yet. We hope to someday, and we would love to open source the whole product. I think what ultimately we are going to be able to do is retain that core HarperDB data model and our data store, and then have everything on top of that, including operations APIs, custom function API, our clustering mechanism. Those can all be open sourced modules where there's simply drop them in a folder and now you have an operations API. Drop it in a folder. And if other people work on that for us, that would be amazing. We are under no presumption that our upcoming solution for clustering is going to be the right solution forever. And we would love somebody with the aptitude and time to suggest something better, faster, stronger. We are focused on meeting the needs of our enterprise customers so we can pay our salaries and develop the best possible experience for our community and our customers. And that takes money. So open source with a service revenue layer, I think it's something we aspire to. You just got to have money in the bank to afford that.
Right. It's not how much a technology costs or doesn't cost. It's like what it's worth, right? So that's what make it a valuable contribution to the community.
We contribute back many of the open source libraries that we have incorporated in our product. Oftentimes, we're using it in unique and interesting ways that ultimately we raise issues. We find packages that have been around, like LMDB. We find new ways to challenge them, and we work very closely with a lot of the maintainers of packages that we incorporate. When we find something, we can push a fix. We can do a PR for them. Ultimately, we don't want to put a load on anybody else in the same way that people hate filing tickets for us. we want to be good stewards of the goodwill that we hopefully engender. So we also do lots of interactions with library maintainers, and we do podcasts and webcasts all the time where we show off their technology. Because obviously we wouldn't be where we are if we hadn't managed to basically stand on the shoulders of some pretty amazing technological ingredients and systems.
Do you have any additional comments before we wrap up today's discussion?
No, I'm just thankful you guys reached out and asked me to talk about the product and the landscape that we are battling against every day. It is truly transformative when you move data closer to people. And like I said, distributing data closer to the edge is the best thing you can do to optimize performance. Nothing you can do internally will ever beat being 1,000 miles closer to somebody, within reason.
Yes. Thank you very much for joining this podcast, Jaxon. It's been a great opportunity to discuss one of the new and innovative databases in the industry like HarperDB and how it helps with cloud native database development efforts that most of the organizations are running into right now. To our listeners, thank you for listening to this podcast. If you would like to learn more about cloud databases or data engineering topics in general, please check out the AI, ML, and data engineering community page on infoq.com website. I encourage you to listen to the recent podcasts and also check out the articles and the news items my team has posted on the website. Thank you.